Alright, so in this fifth podcast on mole conversions, we're going to kill two birds with one stone and just take care of the concept of molar volume. Now, this really isn't an issue until we get into gases more extensively, but for now, since we're covering these conversions, we'll go through it. Now, the rule for mole conversions is that 1 mole of any gas at standard temperature and pressure, or STP, occupies a volume of 22.4 liters. And so you see the conversion factor over here, that 1 mole is equal to 22.4 liters. Now, is it important that you know how to define STP, that you know what standard temperature and pressure is? Not right now. You'll need to know it later, but I'll let you know when that's the case. For now, all you need to know is that at STP, and I will always tell you that it is at STP, 1 mole of any gas occupies a volume of 22.4 liters. So you can assume that a gas is at STP, and that any example for which you need to figure out molar volume is, in fact, a gas. So don't worry about that. Now, here's our first example. We're going to go from volume to moles. So I'm going to ask you to determine the number of moles in 3.24 liters of carbon dioxide, which we know is a gas, at STP. Again, sometimes we may forget to include the at STP part. For all intents and purposes, you can assume that all these gases are going to be at STP, unless we tell you otherwise. And we'll let you know when the time comes. So, just like any dimensional analysis, I'm going to put the conversion factor down here. I know we already have it written up top, but it's never a bad idea to write it where you need it, so then you can refer to it very quickly. So I'm just going to put this in over here. We're going to start with the value that we're given. We have 3.24 liters of CO2. And then in the next step, again, we need to get rid of the units we don't want, so we need to eliminate liters by putting 22.4 liters on the bottom. That way we can cancel out those liters. And on the top, of course, since the molar volume is defined as the volume of 1 mole, that's exactly what we're going to put on the top. So 3.24 liters in our calculators divided by 22.4 gives us an answer of 3 sig figs again, 0.144, actually 0.145 moles of CO2. And again, always important to include your units. Now, while we're at it, I'm just going to go ahead and give you an example of how we would go the other way. And really, the only step that is going to differ here is this step right here. Because in that case, if we're going from moles to liters instead of from liters to moles like we did in this first example, we're basically just going to flip this fraction right here, and we're going to end up with our final answer in liters. So let me show you what this looks like. I'm going to use a different color just for the sake of contrast. And we're going to say how many liters of oxygen gas at STP are in 1.73 moles of oxygen. So, in this case, the method is still the same. We start out with the information that we know. I'm going to go ahead and assume that we already know the conversion factor, so I'm going to start with 1.73 moles of oxygen. Then, if I'm trying to convert to liters of oxygen at STP, liters is always a volume, so we're going to use the molar volume as a conversion factor. So, down here, we have 1 mole of oxygen, because that's what we need to cancel out, and I'll go ahead and cross those out right now. We put 22.4 liters at the top, since that's the number of liters in 1 mole at STP. And now, all we have to do is crunch the numbers. So 1.73 times 22.4 gives us a total of 38.8 liters of oxygen. Again, always important to include your units. So, you've seen both examples of both ways to convert between moles and liters. And everything we need to know about this uses the concept of the molar volume. The concept of that 1 mole of any gas at standard temperature and pressure occupies a volume of 22.4 liters. Thanks for watching.